to learn some math. Math.
Alright, so we're going to talk about tangent lines now, and your learning target is I can use the properties of tangent lines to solve problems. Alright, so there's a couple of theorems about tangent lines that we want to go over real quick. The first one is that if a line is tangent to a circle, remember tangent means that it passes right at one spot on the edge of that circle, right? Right here. Then it is perpendicular to the radius from the center of the circle to the point of tangency, okay? So remember, point of tangency is that point in which it connects with the circle. And so what that means then is that if this is truly tangent, then it will be perpendicular to the radius that is formed from the center to the point of tangency. So this would be a right angle then. That would be a 90-degree right angle. So now, conversely, if a line is perpendicular to the radius of a circle at a point on the circle, then the line is tangent to the circle. So all that says is essentially that if this is tangent, then that's perpendicular. If this is perpendicular, then that's tangent. Okay, it's just kind of the opposites of each other. Now this last one, last theorem about tangent lines, is that if two segments from the same external point, okay, that's this point right here, C, if two segments from the same external point are tangent to a circle, okay, that means the same circle, so both lines come through here, and they are both tangent, then the segments are congruent in length. That means that these side lengths, or these lengths, are going to be the exact same length in measure. They're going to be the same distance, okay? They're going to be congruent in length. So we're going to practice this now. And example 1 wants us to find the segment indicated. Okay, that's this question mark right here. Let's go ahead and call this X. Indicated, assuming that the lines which appear to be tangent actually are. Okay, that means that this line going through here is in fact tangent. And remember, our rule says that if that is tangent, then this is a right triangle. Okay? And if we have a right triangle that is formed by this whole section here, what that means then is that we can use those theorems about right triangles to solve for those distances. Let me just point out real quick though, in case you didn't know this, remember that this is the radius, and the radius is going to be the same no matter or which side it is going to the outside of the circle. So what that means then is that this length right here must be 6.6 as well. If this is 6.6, then this length from the point of from this point on the circle to the center is also going to be 6.6. Okay, so now let's go ahead and use what we know about Pythagorean theorem, okay, to be able to figure out what the distance is from this point right here all the way to the center of this circle. Okay, so we are going to have Pythagorean theorem, which says 8.8 squared plus 6.6 squared is going to equal RC squared. Okay, that's going to be the entire length here. And then let's go ahead and solve for what C is, so we can figure out what the hypotenuse length is. So 8.8 squared plus 6.6 squared, what we're going to do is we're going to use our friend here. 8.8 squared plus 6.6 squared is, in fact, 121. So 121 is equal to C squared. Then we just have to take the square root of both sides, and we end up getting C is equal to 11. Now remember, that's C, which is the entire length from the center to the outside point. We're trying to figure out what this length is, just X, from the point in the external point to the circle. So what that means then is we have to take 11 and subtract 6.6 from it. And we end up seeing that X is equal to 4.4. All right, example 2 says we want to determine if line AB is tangent to the circle, okay? So again, if AB is tangent, that means that this is going to be a right triangle, okay? That should be a right triangle. If that is truly tangent, then that should form a right triangle, which means that 12 squared plus 14 squared will equal 12 plus 8 is 20. 20 squared. Okay, so 12 squared plus 14 squared is equal to 20 squared. The reason why I can say 20 is because if we know that this distance on the external part of the circle is 8, and we know that the radius is always going to be 12, 12 plus 8 is just 20. All right. Now 12 squared plus 14 squared, I don't know that off the top of my head, but I know that my friend can figure it out. 12 squared plus 14 squared, is 340. Okay, so 340. And we want to see, is that equal to 20 squared? 20 squared, go into your calculator, you just see that that's going to be 400. Okay, 340 is not equal to 400, and so therefore this triangle that is formed right here, that line AB is not tangent. Because we can use Pythagorean theorem to figure out that this is not a right triangle. Not right triangle. Example 3 says we want to solve for x, assuming that the lines do appear to be tangent. Remember, if you have an external point and the lines that are connecting to that circle are in fact tangent, which based on our rule, our theorem that we talked about at the beginning, that means that these two lines are going to be congruent. So we just need to solve for x. Therefore, 2 plus x should equal negative 8 plus 2x. And we just want to solve for x. This isn't too difficult. Just get x on the same side, subtract x from both sides. We get 2 is equal to negative 8 plus x. And then finally just add 8 to both sides, and we see 10 is equal to x. So value of x is 10. That's not too difficult. Alright, example 4 says to find the perimeter of the polygon. Remember, polygons are 4 sides. And what we've done is we've built a circle in this here. And we have to, assuming that the lines are tangent, are truly tangent, we can figure out what this perimeter is going to be. Because remember, from an external point, the distance between points are going to be the exact same. So that means that if this is 14, that this has to be 14 as well. And we don't know this side here, so we got to try to figure out what that little length is going to be. So we're going to have to add or figure out what this length is going to be, so we can know what this length is going to be, so we can figure out this length, so we can figure out that length, and finally figure out what those two lengths are going to be. Then we can add everything together, right? So 22.2 minus 14 is just 8.2. So 8.2 is this length, which means that this is also 8.2. And 18.8 minus 8.2 is just 10.6. This is 10.6. And finally, we're going to end up seeing that this distance is 6.3. So x is equal to 6.3 as well. Okay. Now we can just add all of this stuff together to figure out what our perimeter is. We're going to have 22.2 plus 18.8 plus 16.9 plus 14 plus 6.3 is 20.3 plus 20.3. All we have to do is add all of this together and we'll figure out what the perimeter is going to be. 2 plus 8 is 10, plus 9 is 19, plus 3 is 22. Put the 2 up here. 2 plus 2 is 4, plus 8 is 12, plus 6 is 18. 2 plus 1 is 3, plus 1, 4, plus 1, 5, plus 2 is 78.2. So our perimeter of that shape is 78.2.